Right now we want to find the volume enclosed by the two functions y equals x squared and y equals 4x rotated about the x-axis. So first of all, let's just give a quick sketch of the two functions. So we have y equals x squared. It's going to look something like this because it's a parabola. And then we have the function y equals 4x. It's going to look something like this, intersecting the parabola once. And right now we're going to find where the line intersects the parabola. So y equals x squared. And we do that by setting the functions equal to each other. So we're going to set the two functions equal to each other. We're going to let x squared equal 4x, and we're going to find out where they intersect. So solving for x, we get x squared minus 4x equals 0. And factoring out an x, we get x times x minus 4 equals 0. So that means x can either equal 0 or positive 4. And looking from our graph, indeed, this is true. The lines intersect at 0, 0, and it intersects here at x equals 4 and y equals 16. So right now we know the what x is bounded by. So x goes from 0 to 4. So now we want to find the volume enclosed by this, rotated about the x-axis. So if we were to rotate this about the x-axis, we're going to take the area underneath the 4x function, and we'll represent that with this pink color. So the area underneath this 4x function, and we're going to rotate that about the x-axis. And by doing that, we'll get the volume of this cone over here. And we're going to subtract from that the volume obtained by rotating the area underneath the x squared function about the x-axis. So if we rotate this area underneath about the x-axis, then we're going to get this cone-looking shape over here. So if we subtract those two volumes, essentially what we get is the volume obtained if we rotate this area between the two functions across the x-axis, or rotated around the x-axis. So what we're going to get is the difference between the two volumes. So let's set up our equation. So we're going to start off with the pi, and going between 0 and 4, because those are our limits of integration. And we're going to have the volume obtained by rotating 4x around the x-axis. And this is basically the function squared, because we're taking the radius of the function, or the radius of the circle, to be the function at each x. So we're squaring that because the area of a circle is pi r squared, and we're adding all those circles together to find the volume. And we're going to subtract the volume of the inner part, which is x squared. And the same logic applies to that. So this is how you would set up your integral. So if we just simplify this farther, we get pi integral from 0 to 4, 16 x squared minus x to the fourth, all with respect to x. So now if we were to compute this, this would be relatively easy, because by the fundamental theorem of calculus, to compute this, all we have to do is take antiderivatives. So let's do that. we have pi, let's see, so we have pi, the integral from 0 to 4 of 16x squared minus x to the 4th dx. So if we were to anti-differentiate, we would get 16 over 3 x cubed minus 1 over 5 x to the 5th. And we're going to take it with respect to x, and the bounds are 0 and 4. So we're going to plug those numbers in. So what we're going to get is pi 16 over 3, 4 cubed minus 1 over 5, 4 to the 5th. And right now we're going to subtract this with 0 plugged in, but since plugging in x is going to give us 0 in both cases, it doesn't really matter. Right now, if we simplify this, we get 16 is 4 squared, so this is 4 to the 5th over 3 minus 4 to the 5th over 5. So now if we simplify this even further by finding a common denominator, we'll multiply this by 5, multiply this by 3. Then what we're going to get is 5 times 4 to the 5th minus 3 times 4 to the 5th, all over the lowest common multiple, which is 15. And if we keep simplifying, we're going to get pi times 2 times 4 to the 5th over 15. And since 4 is just 2 to the 2, this can also be written as pi times 2 to the 11 over 15.